Welcome to Algebra 2, Unit 7, Lesson 6 Practice Problems. Today we'll start with the vocabulary terms. The first one is normal distribution. If you notice, the first two have a mean of 10, but then the third one has a mean of 8. So you can see that the measure of center, or where the peak of the curve is, has moved to the left in the third one. Then, if you're comparing the standard deviations, you can see that the first one has a standard deviation of 1, while the second and third have standard deviations of 2, and the larger standard deviations are wider than the smaller standard deviation. That's because mean represents the average and standard deviation represents the variation, or how spread out your data is. And a normal distribution is a specific distribution in statistics whose graph is symmetrical and bell-shaped. And that is an important point that you want to make sure you pick up on. It must be symmetrical and bell-shaped. And then you need to know that it has an area of 1 between the x-axis and the graph, and has the x-axis as a horizontal asymptote. The second vocabulary term is relative frequency histogram. And this is a histogram where the height of each bar is the fraction of the entire data set. So we're no longer keeping track of a count of how many times something happens. Anytime we have relative frequency, we're keeping track of the fraction of the entire data, or the proportion or percentage of it. So that's the difference between a regular histogram, where each bar is representing a number of times something happened, and this relative frequency histogram, where each bar is representing how much of the entire data set fall in that category. If you have any questions about either of these vocabulary terms, please use class time to ask for further clarification so you're prepared when you see them on the test. Our first problem says a normal curve with a mean of 500 and a standard deviation of 100 is shown. Shade the region under the curve within 1 standard deviation of the mean. So if we have a mean of 500, then that means the average is right here in the middle. Most of our data points are going to fall on that mean location. Then there is a standard deviation of 100. So that means 1 standard deviation below would be at 400, and 1 standard deviation above would be at 600. So we can call this the mean. This is negative 1 standard deviation. And this would be positive 1 standard deviation. And then they want us to shade in the region underneath it. Next, they ask how much of the data falls within the shaded region. So this is where we're going to learn a new rule. When we have normal distribution, we have what we call the 68, 95, 99.7 rule. And that means 68% of all results are within one standard deviation above or below the mean. And that's what we have here. Between 400 and 600, that is 68% of all the results. So just over 2/3. The next part of that is that 95% are within 2 standard deviations. And lastly, 99.7% are within 3 standard deviations. So this means if a result is more than 3 standard deviations above the mean, or more than 3 standard deviations below the mean, that is a 3 in 1,000 chance. If you have any questions about the normal distribution 68, 95, 99.7 rule, please ask for clarification. This is a main topic of understanding in statistics. Memorizing this rule will help you solve many normal distribution problems without actually having to do any math, as long as you understand these distributions. Next question. The stopping distance of a certain car traveling at 60 miles per hour follows an approximately normal distribution, with a mean of 130 feet. So that's going to be an important factor. And a standard deviation of 5 feet. Approximately what percent of the time does the car stop at a distance of between 120 feet and 140 feet? So we can do a diagram here. If we have approximately normal distribution, we have our bell-shaped symmetrical curve. And we're saying that the mean is at 130 and the standard deviation is 5 feet. So if we go 5 feet to the left, and we're at 125, that's minus 1 standard deviation. Well, if we go 1 standard deviation to the right, then that's 135, and that's 1 standard deviation above. But we want 120 and 140. That means we need to go another standard deviation. Now we're at 120, and that is -2 standard deviations. And we need to go up another standard deviation to 140. That would be +2 standard deviations. If we are going to go 2 standard deviations, then remember that is 95% of all data points. So 95% of the time the car stops between 120 feet and 140 feet. It'll be 65% of the time between 125 and 135, but it'll be 95% between 120 and 140 because it's 2 standard deviations. If you have any questions about how to answer a problem like this practice problem, please use class time to ask for further clarification so that you're prepared when you see it on the test. Our last practice problem for Unit 7, Lesson 6. The distribution of weights for bags of chips is shown to follow an approximately normal distribution as seen in this histogram. The weights of approximately 95% of the chip bags fall within the shaded region. Number 1. What is the approximate mean weight of a chip bag? So if we want the mean, and this is a normal or approximately normal distribution, then the mean should be in the middle. So we could say the mean is approximately 10 ounces. Number 2, what is the approximate standard deviation of the weight? So if we want standard deviation, and they've told us 95% fall within the shaded region, remember the 68, 95, 99.7 rule. That means the shaded region between 8.8 and 11.2 represents 95% because it is 2 standard deviations. So if we want 1 standard deviation, we need to go from the mean to the end of the 2 standard deviations. We know that this is 2 standard deviations. So this is a difference, 11.2 minus 10.0 equals 1.2. So if we take 1.2 and we divide it in half, then 1 standard deviation is 0.6. So here at 10.6, we would have 1 standard deviation. And then down at 9.4, we would have minus 1 standard deviation. So the approximate standard deviation equals 0.6 ounces. If you have any questions about the normal distribution 68, 95, 99.7 rule, please use class time to ask for further clarification before we move on to the next lesson and before you have to take the mid-unit test.